Hello friends. Now we are going to discuss about covalent bond. Covalent bond. How can we explain about covalent bond? In the previous concept we have discussed about ionic bond. Ionic bond, usually what we discussed, the complete electron transfer from metal atom to non-metal atom we have discussed right now. Here in the covalent bond, sharing, like mutual sharing. For example, if one atom is having a one electron and another is having a one electron, they both needs one more electron each other. So that is why mutual understanding between the atoms. That is what we can say, mutual sharing between the atoms. That is called covalent bond. Okay. So I'll show you how to explain about covalent bond. For example, homodiatomic molecule I am taking first. For example, when you are considering the homodiatomic molecules, here what will happen? Like hydrogen, how many electrons are there for hydrogen? One electron, right? Lewis dot structure. And another hydrogen, another electron. So both the atoms are having one electron each. Okay. So these both will share it equally. These both, and they will form a molecule, like like this hydrogen molecule. Okay, so one electron of hydrogen atom, then another electron of another hydrogen atom, both will gain the nearest noble gas configuration of which one? Helium. That is 1s2 duplet configuration, we will say, right? Helium, the only one that is having a duplet configuration with K shell. Okay, so this we will say about the hydrogen atom. So we can write here covalent bond H, single bond H. This we are calling single bond. This is solid line. This solid line only represents single bond. This solid line only represents single bond. And here two electrons are involving in the bond formation, right? So this is what we are calling a single bond, and this we are calling bond pair. Next you take example of oxygen. Oxygen, Lewis dot symbols you take, belongs to which group? Oxygen, sixth group, sixth A group. So how many electrons? 6. So 1, 2, 3, 4, 5 and 6. Okay, 2 electrons are there here. And another oxygen you take, 1, 2, 3, 4, 5 and 6. Okay, so here one is this is a pair, this is a pair, and another here 2 single electrons are there. These single electrons, what will do? These single electrons will try to attract towards about that, and this electron will form each other a bond, right? So this electron here, these 2 electrons we are calling as a bond pairs. These 2 electrons we are calling as a bond pair, and these 2 electrons we are calling lone pairs. Means they are not involving in the bond formation. Okay. So because of these 2 electrons are involving in the bond here pair, so oxygen will form here multiple bonds. That is O double bond O. O double bond O. Multiple bonds in the sense what we can say here? Double bond and triple bond. Double bond. This is double bond. Okay. So this is about the oxygen atom. Next you take nitrogen atom. Nitrogen atom. Even what is the valency of nitrogen? 3. And number of valence electrons will be 5, right? So 1, 2, 3, 4, and here the 5th we will write here. And nitrogen, another nitrogen also you take. 1, 2, I will show with the cross marks. 1, 2, 3, 4 and 5. Okay. So here even this dot I am mentioning here because to understand it easily. Okay. So now you take with another atom's nitrogen molecule. This is one atom. This is one atom. And the electrons of this here will attract this one. And here this will attract lone pairs. Okay. So because nitrogen valency 3. So combining capacity of nitrogen will be 3 only. And here this is called lone pair. This is called lone pair. Okay. So how many bonds here can form with the nitrogen forming another molecule? This is 3 bonds. And triple bond N. We can say it as a N2. N triple bond N. Okay. So this is triple bond. Triple bond. 3 bonds are there. This is triple bond we used to call it as. Okay. And this, see, you can ask then 4 electrons, 4th bond. Is there any chance? No. No chance of like that. Okay. Only 1, 2 or 3 bonds only can able to form when covalent bond is forming. Right? So I hope next another example I will give you. So examples of here hydrogen H2, N2, O2, F2, Cl2, Br2, I2, etc. Many we can take here like this. And another example I will show you with carbon I will show you. What is this? Carbon, right? 4 hydrogens are binding with the carbon. I will show you with the normal first configuration of electronic configuration of carbon 1s2, 2s2, 2p2, right? Carbon 6 atomic number. So 6 electrons are there. So which is the outermost shell here? This is the outermost. So how many number of outermost are there? 4 electrons are there. So we can write carbon 1, 2, 3, 4 outermost electrons. Okay. So 4 bonds can form carbon. So now hydrogen 1s1, 1 electron only in the hydrogen. Okay. So these hydrogens, when you are drawing the structure of carbon, like central atom is the carbon. Okay. One atom's carbon electron, here it will attract towards the another atom's hydrogen, and here another hydrogen and another hydrogen. Okay. So like this, another hydrogen and another hydrogen. Okay. So 4 hydrogens here, these 4 hydrogens are forming a bond. Here these 4 hydrogens are forming a bond. Okay. So carbon valency is satisfying, given hydrogen valency is satisfying with one single bond, and here carbon also satisfying with 4 altogether, 4 single bonds are happening. Okay. So like this we can give the examples of covalent bond. Then how can you able to explain about this, and what are the types of covalent bond? How we are explaining the types of covalent bond. Types of covalent bond when you are seeing like polar and non-polar. 2 types of covalent bonds we are explaining here. Polar, non-polar. Polar in the sense even based on the charge polarity we can say, and non-polar means we can say it as a pure covalent bond. Non-polar means pure covalent bond. That covalent bond completely it forms. Just now non-polar covalent bonds we can able to explain with like diatomic molecules, the same atoms, and electronegativity value, electronegativity C, pure or non-polar, and here polar covalent bond. Okay. So polar covalent bond. So just now what we discussed here, examples just like hydrogen, nitrogen, Cl2, F2, and even Br2, I2, CH4, methane, etc. we have discussed, right? So all these covalent bonds, like all these covalent bonds, formation of these covalent molecules, the En value differences, En difference is equal to 0. En difference is equal to 0. Electronegativity difference of these particular atoms is equal to 0. Okay, 0. When you are considering to the ionic bond, what we discussed there, En electronegativity difference will be greater than 1.7, right? The metal atom and the non-metallic atom. But here En difference will be 0. Okay, because the same atom. For example, when you are considering here 0.9 electronegativity of the hydrogen, 0.9 minus 0.9, 0 only will give, right? So this is the reason En difference will be. And when you are considering to the polar molecules, polarity will be there. Polarity based on the charge, we can say. Polarity. By applying of charge, it will take like partial positive charge and partial negative charges, we can say here. Okay. And here electronegativity, En value difference will be, En difference will be here less than, greater than 0, less than 1.7. So we can write here simply less than 1.7. Okay. So like this we can say. For example, I will show you how to explain about non-polar covalent bond. Okay. Polar covalent bond I will explain you. Okay. So just including with the electronegativity and the charges, everything I will explain you. Just this is a very easy concept actually. So now you see here, like just what we have discussed, hydrogen chloride molecule you take, HCl. Okay. So HCl, what is the configuration of hydrogen? 1s1. What is the configuration of chlorine? 1s2, 17 atomic number. So 1s2, 2s2, 2p6, 3s2, 3p5. This is the configuration of chlorine, right? So first shell, second shell and the third. Which is the outermost shell here? This one, M shell. So what is the outermost configuration here? 3s2, 3p5. Outermost configuration here we can say 3s2, 3p5. So how many electrons it needs to gain the stability? 1 electron, right? Which is the nearest noble gas? 18, that is argon. And what about the hydrogen to gain the nearest noble gas? 1 electron, that is the nearest one is helium. So hydrogen also needs 1 electron. Even argon also needs 1 electron to gain the nearest noble gas, right? So how these both will share each other? Actually hydrogen when you are considering only 1 dot, like 1 electron. And chlorine when you are considering like 1, 2, 3, 4 and the fifth one. Okay. So 7 electrons are there, right? 6, 7 electrons. So this, see, hydrogen is the smallest element, atom, and the chlorine like a bigger size compared to this, right? Atomic number of 1 electron, and here 17 electrons are there. In that 7 electrons are there in the valency shell, right? So here, these two, there is no here in the polar, non-polar covalent bond, we discussed it clearly, they are gaining. And the electronegativity values you take here, 0.9 and 3.0. Okay. So which is a bigger value here? Chlorine, higher electronegative value. So when you are applying the charges here on this molecule, it will take a partial positive charge and partial negative charge. Okay. So that is the reason here when these two are forming a molecule, means H plus Cl. We can say it as a HCl. Okay, hydrogen chloride. It is forming as a single bond H, single bond Cl molecule. Okay. So here electronegativity's difference will be, you consider here 3.0 minus 0.9, how much here? 2.1. Okay. 2.1. So this is less than, like this we can able to say here. Sorry, not 2.1. This is 1.9. Okay, 1.1. This is less than 1.7. Okay. So based on this, we can able to explain about HCl molecule polarity. And in case of like any element you take, any element, and these atoms like AB, when you are considering AB is a hetero, two dissimilar atoms. Okay. These two dissimilar atoms, they are forming any one, like depends on the electronegativities. The shared pair attracted towards the highly electronegative atom. Shared pair attracts towards the highly electronegative atom. Because of that, B atom like more electronegative, so it is gaining the negative charge, and the A atom is gaining the partial positive charge. Okay. So based on this, we can explain about the covalent bond, polar covalent bond. Okay. Then